In the next couple of videos, we're going to be looking at different classification methods. And so let's just briefly take a look at what it is to be a classification model. A classification model is going to identify what group, so we're looking at nominal data here, what group that a particular data point belongs to. So if you think about the data here, let's suppose that we have two variables, whatever's on the x-axis, whatever's on the y-axis. And so then we can take our data. So you think about it, we have two questions in a survey. Maybe one is related to age and the other was related to height. Okay, so what we have here is that we then have those individuals who are in different parts of this graph depending on those age and height. And so what we're doing is we're trying to identify what group they belong to. So maybe we have different families we're trying to identify. And so what we would do is we have labeled data with our classification model. And so this is supervised learning. So we already know for the data which groups people belong to. And then what we're doing is creating a model based on those variables and checking the accuracy of it to see how well that model performs. So we're going to train the model. We're going to test it, see its accuracy. We can tune it, try to get a better model. So that when we have a new data point, we can look at these relevant variables and be able to identify what group it belongs to because we have trained our model based on labeled data where we have all the variables and we know what group they belong to. So if you look at this on a graph here, here we have the green group and the blue group. And so if this is age and height, what this starts to tell us is that height is really not relevant, but age is. So there's the older green group and the younger blue group. And so if we brought along a new data point, a new individual, we could then identify what group they belong to based here on this relevant variable. So likely they would be in that older green group. So classification models, we are labeled data. We already know what group they belong to. And so then we're looking at multiple variables, doesn't just have to be two, to see if we can create a model that can identify the label. And then we have a new data point that we then will be able to predict the label of. The classification, here we have it's binary, or green or blue, but different models are going to have, some models will only allow for a binary, one or the other, and others will allow for multiple categories. So we'll look at different classification methods. Some are used for text, and we'll look at when you use different ones. We just want to contrast that with cluster analysis. With cluster analysis, this is an unsupervised learning method. We don't already have the labels. We don't know what groups these data points belong to. So we have different variables we'll consider, whatever's on the x-axis, the y-axis. We're not limited to two variables. We can look at more. But the key with the cluster analysis is because we don't already have the labels, we are simply trying to identify cohorts or groups in the data set that might be potential labels. So we might label this group with one name and this group with another name and this group with another. So we don't actually have an ability to determine the accuracy of our model initially because we don't have those labels. We are then simply trying to find groups and what they have in common to create those labels. So that's cluster analysis, which is unsupervised learning. And right now we're going to be focusing on classification models, which is supervised learning and has labeled data. There are different types of classification models. I don't know why I have O capitalized there in that second one. But the ones that we're going to focus on are the k-nearest neighbors, the generalized linear model, the support vector machines, decision trees, random forest, and gradient boosting machines. There are even more classification models, but we'll focus on just these couple to get you into how classification models work. So the key here is to identify what is the appropriate model based on your data. So like all the things we're learning about here, the key is to know which tool is appropriate when, to be able to interpret the output of it, and to be able to do it in Python. Those are the three things we care about for any of these topics. When do you do it? What does it tell you? And how do you do it in Python? So we're going to come back to this page after we've gone through the different models, but just a key here is to know when you use which one. So if you have missing data, we want to focus on the k-nearest neighbors or the naive Bayes. If our label is binary, so we only have two predictor variables. Oh, sorry, let's try to get back in. If our label is binary, so we're predicting in the green group or the blue group, right? Two options. And we only have two predictor variables, like having that x and y axis, then the general linear model is going to be the easiest one to explain to people. If there's lots of overlap between the groups, if it's really hard to distinguish kind of that green and blue, if we go back here they're pretty well separated, right? Green, blue. If there's a lot of overlap, then the generalized linear model is not going to be as appropriate. If we have a predictor variable that is nominal, okay, so then what we're using categories to predict another category. Then we want to use the method called naive Bayes. If we only have two predictor variables, think x, y axis, then the k-nearest neighbors is the easiest to visualize. We can show it as a graph. If we actually have a lot of overlap, if those blue and green dots are all kind of mixed, then the k-nearest neighbors is a really good one to use as well. If we have lots of predictor variables, so not just the x and y axis, but we have even more variables we're trying to use to predict the label, and our sample is very small, then we want to use the support vector machine. If you're unsure what predictor variables you should use, so we don't know what is on that x and y axis because we have lots of variables, but we're really not sure which ones are relevant, then we can use methods like decision trees, random forest, or our GBM, our gradient boosting machines, to help us identify which of the variables are actually relevant. When it comes to those decision trees, random forest, and general gradient boosting machines, they work well too if your groups are unbalanced. What do we mean by that? Well, you can see here we have slightly more blue than green. If it's a big difference, if there are a lot of blue and a tiny amount of green, you really have unbalanced in terms of the groups. And so then using the random forest, decision trees, or the gradient boosting is the better methods. If we have more than two predictor variables, so here, I don't know why it keeps moving around. Here, when we're looking at this image, there are two predictor variables. One that's on the x-axis we said was, say, age, and one here that we said was height. That's only two variables to try to predict these two labels, blue and green. Now, if there's more than two predictor labels here, we can't really put it on a graph, right? So then we're looking at models that would help us visualize that. So if you want to visualize it and you have more than two predictor variables, then you want to go with a decision tree. And we'll look at why that is when we get to the decision trees. If you're overly concerned about false negatives, so we'll look at how with classification models we can assess the model. Because we do know the labels, right? We know that this is blue and we know this is green. We can actually look at how well the model performs. Does it actually say that this should be blue? Does it say that this should be green? So we're going to look at things like false positives and false negatives. If you are very concerned about false negatives, so it's very risky for you to say something is not something when it is. For example, in medical research, saying that you don't have cancer when you really do, then you want to use an approach like a random forest. And then finally, if you have really large data sets, you have tens of thousands of data points per variable, then we want to use the gradient boosting machines. So we'll come back to this list once we've gone through these different classification models. But the key here is to identify which classification model is relevant for what you're trying to accomplish. How many variables are you using to predict the label? How big is your data set, right? Is it very small? Is it very large? Is your data set balanced or unbalanced in terms of How many are making up each of the items in your label when you're testing? How much overlap is there in terms of that data? Are they quite separate and distinct, or are they quite blended and mixed together, which can make it really hard to identify which classification it belongs to? And then we look at, do we have nominal data? Do we, in our predictor variables, is it ordinal, ratio, interval? Those types of things are going to impact which methods we use. So in the next couple of videos, we're going to go through all these different classification models.